Hello everyone, welcome to Global Minima channel. Today we will discuss what is Dropout and how we can use it to improve our training performance of a neural network. So what is Dropout? Dropout is a regularization technique. Before we understand regularization, we need to understand what is overfitting. So whenever you are dealing with a machine learning algorithm, you might have come across these three terms: underfit, goodfit and overfit. Underfit is when the capability of the model is less such that it could not capture all the complexities that are present in the dataset. To give an example, if you see the left figure, you see that the dataset is looking like a complex curve, but we are trying to capture it using a simple straight line. The capability of the model is lesser than the complexity of the dataset. This is called as an underfit. What is overfit? Overfit is the opposite of that one, where the capacity of the model is too high such that it could keep all the data points in its memory itself. So you could look at the rightmost figure. You could see that we are trying to capture every data point, pattern of every data point that is present in our training data. That is called as an overfit. And why is overfit bad? So overfit, you can think of it similar to a student who mugs up all the questions that are present in his textbook and tries to achieve 100% accuracy in his exam. But what happens in the exam? If there is a slight variation in the question, he would not be able to answer it. So the same thing would happen with the model as well. If there is slight variation in the data, the model will not be able to give good results on top of that one. It will only give good results on what it has already seen. So this is the problem with overfitting. So how do we know when we are overfitting and when we are underfitting? So say when your training accuracy is less than 100%, that means that the train accuracy is staying something around 80% or 90%, just to give an example. That means that it is an underfit. We have not completely fit the training accuracy to 100%. And then what is overfit? We can identify overfit by observing both the train accuracy and text accuracy. With the train accuracy and text accuracy, there is a lot of difference between both of them. That means it is an overfit. So there are various regularization techniques which you can use to combat overfitting, and we will be talking about one such regularization technique today, that is dropout. Now let's try to understand what is dropout. Dropout is the technique of dropping random nodes in a particular layer based on a probability. So for example, when you see this figure, you could see that two random nodes are dropped every iteration. And this is possible due to the probability p equals to 0.5 that is mentioned for this layer. So when I mention p equals to 0.5, it means that half of the nodes that are present in this layer are randomly dropped every iteration. And when these nodes are dropped, the corresponding connections are also dropped. So your standard neural network looks like this. And when you apply dropout, it looks like this. So the dropped out network is a subset of the main neural network. So this is how dropout works, and dropout can be applied across every different layer, and it can vary across different layers. So I can mention 0.2 dropout for my first hidden layer, I can mention 0.3 dropout for my second hidden layer, and so on. This is a hyperparameter which can be tuned. We have understood what is dropout. Now let's try to understand how dropout helps in regularization and how it helps to combat overfitting. So the first point, dropout helps in the network being over-reliant on a certain number of nodes. So what does this mean? When the neural networks are trained, the behavior that is observed is a few certain nodes take up the entire responsibility of doing the classification task, and there are many other dormant nodes which doesn't add much value. This is similar to a group project. If you are having 4 students in the project, there are only 2 students who work a lot to complete the task, but the other students are just lying there, doing not much help. So this is the problem in a neural network as well. And dropout combats it by randomly dropping random nodes such that equal importance is given to all the nodes. So the nodes which were sleeping previously also need to take up responsibility, because there are chances of the important nodes getting dropped at any iteration. The second point, what dropout does is it reduces the capacity of the network. We know that overfitting happens when the capacity of the network is huge. And how dropout combats it? It drops randomly certain number of nodes in the network. Now the entire capacity of the network, which is a subset of the main neural network, is lesser. And because of this, when we train this lesser network to do the same task, it won't face the problem of overfitting. And the third and the most important point is dropout is similar to an ensemble of neural networks working together. Everyone must have been aware of what is an ensemble of models. For example, when you are taking random forest, you would have seen that random forest is nothing but an ensemble of decision trees, taking decisions from multiple trees. And whenever you are taking decision from multiple models, right, what you will observe is the output you will be getting will be much more better, much more regularized. Same thing is happening here. Since we are finding a different kind of structure in every iteration, right, a different kind of neural network, a different kind of subnetwork that is present in every iteration, it is similar to having a lot of neural networks which are driving together the task of classification. Because at the test time, we don't drop any nodes. Although we are dropping nodes at the train time and we get a different neural network to solve the same task of classification at every iteration, at the test time we have all the neural networks working together for us. Only thing is, because the outputs will be higher, we try to multiply it by a factor to make sure that it won't cross the limits. But apart from that, since all the nodes will be there at the test time, it is similar to having an ensemble of networks working together to give you the best result that is possible. And that is why dropout performs the regularization and reduces the gap between training and testing accuracy. Thank you everyone. We'll meet you in next video where we'll be talking about some other regularization techniques which we have not covered at this part of the class.